Okay, this is Mr. Pistone with the acceleration test review. Let's begin on question 1. Okay, questions 1 through 5 are all word problems, so we're going to use the problem-solving template to solve those. Starting with question 1, write down the template looking for, given, formula, and solve. Okay, in question 1, Jake rode his bike around Longview Lake. He had an acceleration of 5 kilometers per hour squared for 3 hours. His final velocity was 20 kilometers per hour. What was Jake's initial velocity? So that tells us what we're looking for. So I'm looking for V initial. Okay, first thing I'll do is go down and write down the formula. V initial equals VF, V final, minus acceleration times time. Still write it down. With me. Okay. These three variables must be given. So I'm going to write those down in the given section. VF equals A equals and T equals. Now look back through the problem and find those. He had an acceleration of 5. It took him 3 hours, that's time. And his final velocity, or his VF, was 20. To solve it, just plug those values in. 20 minus acceleration times time. I'm going to put those in parentheses, and that will even keep your calculating a little bit more neat. Acceleration is 5 times time of 3. So we've got 20 minus 15. Velocity initial of 5. Okay, that's question 1. And the answer was letter D. Okay, now notice I didn't even look at the answer choices. I'll uncover them now and find out, okay, there's the one that I solved, which was correct. Okay, alright, question 2 also requires a template, so I'll get that ready. Looking for, given, formula, and solve. Let's take my work out of the way for a minute and read the question. Okay, in this question, a parachute on a racing dragster opens and changes the velocity of the car from 200 to 75 miles per hour in a period of 2.5 seconds. What is the acceleration of the dragster? Okay, so on question 2, again, we're looking for acceleration again. Okay. Oh no, I guess it's the first time we're looking for acceleration. Okay, what is the acceleration? Looking for A. Come down to the formula. Write down the acceleration formula. It's the change in velocity, or VF minus VI, over time. These three variables right here need to be in my given section. So I'm going to get them ready. VF equals, VI equals, and time equals. Now I'll look back to the problem and fill those in. Okay, the racing dragster opens and changes the velocity of the car from 200, so that would be the initial velocity, to 75 in a period of 2.5 seconds. Let's plug those into our formula and solve. VF 75 minus 200 divided by time, 2.5. 75 minus 200 is negative 125 divided by 2.5. This is going to be one of the most common mistakes if you maybe miss this problem, is getting your velocity final and initial mixed up. Okay, so read through the problem carefully and make sure you have those in order. Okay, negative 125 divided by 2.5 is going to be negative 50. This is an acceleration, so our units would have been miles per hour per second. So this is a good example of the acceleration units are distance over time, but we couldn't do distance over time squared because our two time units are different time units. Okay, let's go on to question 3. Okay. Taking a look at the question while I get my paper ready. A cart rolling down an incline for 6 seconds has an acceleration of 5.5 meters per second squared. If the cart has an initial velocity of 3, what is its final velocity? I told you not to. Okay, we're looking for what is its final velocity. So I'm looking for VF. Come down to your formula. And VF is equal to VI plus acceleration times time. Okay, I can solve for VF, but I need to be given this, this, and this. So I'm going to write that in my given section. VI equals, A equals, and time equals. A cart rolling down an incline for 6 seconds, that's the time, has an acceleration of 5.5. If the cart has an initial velocity of 3 meters per second, there's my VI, what is the VF? Solve it. VI is equal to 3 plus A times T. 5.5 times 6. Okay, and I'm going to bring the calculator in just to show you how you could punch that into the calculator. If you want to punch it in all in one sequence, you could do 3 plus, and then make sure you include your parentheses. 5.5 times 6, and then end your parenthesis, and there's your answer of 36. That's question 3. Alright. Let's do question 4. Okay, question 4. Hillary pushes off her skateboard at the top of a hill. She starts with a speed of 3 meters per second and gains speed steadily, accelerating at 1.5 meters per second squared. Her speed at the bottom of the hill was 18 meters per second. How long did it take her to get to the bottom of the hill? Okay, so question 4 is saying how long. How long we know means time. Question 4, I'm looking for T, given, formula, solve. I'm looking for time. Let's write down our time formula. Time equals the change in velocity over acceleration, so VF minus VI divided by A. All right. I can solve for T, but I have to be given those 3 things, so get your given section ready. VF equals, VI equals, and A equals. Okay, look back through the problem. With Hillary, pushes off of her skateboard at the top of a hill. She starts with a speed of 3. So starting with a speed would be an initial velocity of 3 meters per second. Gains speed steadily, accelerating at 1.5. There's the A value, meters per second squared. her speed at the bottom of the hill, sounds like a final velocity, was 18 meters per second. Okay, to solve, plug those values in. VF is 18, minus VI is 3, and divided by A, 1.5. Yes, this one I definitely want to put this one in the calculator to show you. Again, if you want to punch this in as one sequence, the first thing I'm going to do is show you the common mistake. The common mistake is to go like this: 18 minus 3 divided by 1.5. Okay, that's a common error, and here's why. The calculator is going to do the order of operations, and the first thing it'll do is do 3 divided by 1.5, which will be 2, and it'll give you 18 minus 2 equals 16. Okay, that's incorrect. To do this correctly, you need to keep the 18 minus 3 as one term in the numerator. To do that, use parentheses. 18 minus 3, end parenthesis. Now that's the number 12 in the numerator, divided by 1.5 equals 10. Okay, so that's the correct way if you want to punch it in the calculator all in one sequence. That's the way to do it. Okay, and we're going to skip question 5 because that deals with the acceleration again. That's very similar to what we've already done. Let's move on to question 6. Okay, this is the beginning of graph analysis. Okay, now one of my common test-taking strategies is to do this: cover the answers. Don't even look at the answer choices yet. Okay, the question is, choose the VT graph that corresponds to the XT graph below. And I give you a hint: draw tangent lines on the XT graph. So, on your paper, why don't we draw this XT graph? Okay, draw this curve, and then we will draw our own VT graph. Give yourself quadrant 1 and 4. Okay. First thing we ask ourselves is this slope positive or negative? And as we look at the graph left to right, it's going down, so that means it has a negative slope. And since the slope of the XT gives velocity, this means we're going to work in the bottom quadrant where there are negative velocities. Next, after we've determined that, you may want to put just a little circle around that quadrant so you know that all of your work needs to take place down there. Then draw tangent lines. Remember, tangent lines pass through one point on the curve. That's a very shallow tangent line. Shallow means slow on an XT graph. Then you would end with a very steep tangent line, and steep means fast. So this object moved in the negative direction, and it went slow to fast. It sped up. So in this quadrant, we need to go slow to fast. Where is slow located? Slow is always close to 0 velocity, which would be here. Okay, so here's slow, and fast is far from 0. Slow to fast. Alright, now I did all of that work on my own. I haven't even looked at the answer choices yet. So as a student, I would then uncover these and choose the correct answer, which would be letter B. Okay? It's important to kind of do the work on your own, trust on your own intellect and what you've learned so far, and then go back and choose a correct answer. Let's go to question 7. Okay, more graph analysis. Okay, again, let's choose the VT again. So let's cover our choices. Let's draw the XT graph they gave us for our study guide.